Hi there once again, and welcome to another Expresso mechanic tutorial. And in this one we're going to be building what you see in front of you here, and this is actually a dynamic fluid simulation. So if we run the timeline and we start moving the beaker around, you can see that the fluid actually reacts accordingly. It's not particle based, so it does have its limitations, but it's quite nice and it can be used in a number of different scenarios. We can also, if we select a rotation, we can rotate the beaker and the fluid will react accordingly there too. So, as I say, quite a versatile rig and quite a nice little rig for certain types of simulations. You can also see that there's some rippling going on the surface, and that's done with a combination of the shader and formula effectors, and these can be switched off if you don't want them. So, or you can have one or the other or both. So there's options with it. But if you want a completely flat fluid, you can just switch that off. Anyway, that's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We'll start by bringing in a null, and we'll name this Dynamic Fluid Sim. And we'll place everything that we bring in subsequently into this null. We'll start by bringing in a cylinder, drop this in here. And this is just going to act as a guide for us, and we'll make it 20 in its radius and 90 in its height. And in our coordinates, we'll place the cylinder at 45 centimeters along its y-axis, so that we've got it sitting on the floor. Just hit O for object so that we can see it more closely. Apart from that, we can just leave it as it is. We don't need to do any adjustments. We'll give this a render tag and it will be a display tag. We'll use it and we'll select lines and also isopalms. Fabulous. So we've got that set up so far. Moving on from here, I'm going to bring in a sphere, drop this into our dynamics here, make its radius 5, and we'll place it somewhere around here. Around 60, let's go 60 high. That'll do nicely. We can then command drag to copy this sphere, and we can make this one 10 in its radius, and we can leave everything else the same. We'll bring in a cube, and this cube will make 10 in the X, 10 in the Z. In fact, that's a bit big. Let's make it 5. That's fine. That's better. And we just need to make it something like 80 or maybe even less. Let's go 60. And then we can just drop this so that it fits inside the cube, inside the sphere, I beg your pardon. And we'll drop this into there. Now this sphere here, I'm going to rename it theta. And of course, theta is the name given to an angle in Greek. And there's a very good reason why I've given it that name, and you'll see why a little bit later in the tutorial. Okay, so we've got those two and we've got our cylinder. Moving on from here, let's bring in a dynamic connector, and then we can think about setting things up. So we'll bring one of those in, we'll drop this between the two of them, but we'll just put it into the first sphere and zero out so that we get it in the position that we want it. We'll just take that out of there. Now this connector will need to be a ball and socket. Okay, that's the kind of connector that we want. In our display, I'm just going to make it 10, just to make it a little bit smaller. And then we can think about placing our objects in. Now at the moment, neither of them are dynamic, so we'll make the sphere, the small sphere, we'll make that a collider body, and theta we will make a rigid body. Okay, so we've got that set up, and then we can work with our connector. In our object tab, object A needs to be our sphere, and object B needs to be theta, and we can leave that set up as it is. Now, if we run the dynamics, we can see at the moment the cube is falling away from theta. So we need to select our dynamic tag here, and we need in the inherit tag to say compound collision shape. Everything else we can leave as it is. Now if we run the timeline now, we find that doesn't happen. If we select our dynamic fluid and we run the timeline and start moving this around, we can see that we're getting a nice result. We're actually getting it moving around the way we would expect it to. And that's great. That's what we want. I'll just add some more frames. I'll give it 1,000 frames for what it is so that we've got a bit more time to play with. Fantastic. So we've got our dynamics well and truly set up, and they're working exactly as I want them to. Now, neither of these objects need to be visible. So if we take away these two and we also take away our small sphere 2, we're getting the result that we now want. We've got the dynamics, but we're not seeing any of it, and we don't need to. Fantastic. So we've got it that far. Moving on from here, we can think about bringing in some more elements and starting to work to get the fluid actually working. We'll bring in a circle, set it in its XZ plane, make its radius 20. Now, it doesn't need to be a circle, it needs to be an ellipse, and we need both radii to be 20. Okay, so that's essential. If we drop our circle into our dynamic fluid, we can zero it out just to make sure that it's in the correct position. And what we'll also do, in fact, is zero this out. Let's just get that correct so that everything is zeroed when we start. Okay, brilliant. So what we'll do here, if we move this to 60, so that's the top of our fluid, we can then copy this one and zero out, and then the pair of them can be dropped, if we hold down our Command and Option keys, into a loft. And we've got that. Now, our caps, we don't want the start, we just want the end, and we can leave everything else as it is. And in our object, our U subdivision, if we just switch to garage shading lines and we leave it in wireframe, we can see what we've got there. We can set this to 2, really. We don't need to worry so much about that. But our subdivision U will make 60, just to make it that bit smoother. And we can leave everything else as it is, and we can now switch back to isopalms. And we've got that set up so far. Now, we do obviously want to block the end of this off, but we're going to do that by creating an extrude. If we copy this circle and then we drop this into an extrude by holding down the Option key, so we'll get an extrude, we've done that. In the Object tab, we need to set this to just 0.5. That's perfectly good for what we need. And we can then think about working with our caps. Now, we only want a start cap, so we'll take away the M1. The tessellation needs to be quadrangles. In fact, regular grid is better than quadrangles. Let's go regular grid, and we'll make the size 1. And if we just check that in wireframe mode, we can see that we've got quite a tight grid there, and that's what I want. Okay, so that's all looking really nice. Let's just go back to isopalms. Fantastic. So we've got our extrude set up and we've got our loft set up, and they're all looking really good and they're going to work nicely for us. The next step to get this to actually behave like a fluid is to work with Expresso. Let's bring in a null object and name it Expresso. We'll give it the Expresso tag. We've got our window open and we're ready to start work. Now, the first thing we're going to do is bring in theta. And at the output stage, we'll give it rotation P and rotation B. We'll start with rotation B and we'll give it rotation P. Now, we know that the sphere theta, when we move our dynamic fluid around, we know that this is basically a pendulum, and it's the fulcrum for a pendulum. It's at the center point. It's the point of rotation for the pendulum. So that means that the theta is constantly changing, and if we go into its coordinates, rotation P and rotation B will be giving us constantly changing angles. And that's going to be important for us because we're going to need those angles, and we're going to need to work with them with a bit of trigonometry in order to make the radii of our circles change to the correct lengths in order to simulate the way the fluid is moving around inside a beaker technically. So let's think about how we're going to do this. Well, the first thing that we can do is bring in two trigonometric nodes. So let's get one of those, and then we'll set this up. Its function needs to be cosine. Let's just command drag to copy this one, and we can plumb the outputs from theta into the value ports of both of these. I'm just going to shut this down and we'll do a little bit of mathematical theory. Now if we switch to our right hand view, so F3, hit H so that we can see everything. Now let's think about this. We said we were working with the cosine. Now if we think about a triangle through here, a right angle triangle, theta we know is going to be the angle of our right angle triangle. If we just put that through there, and we know that this length is a constant 20 because we know that this is the radius of our cylinder. So if we divide 20 by the cosine of theta, it will give us the length of this hypotenuse, this invisible hypotenuse of our right angle triangle. And that is how this is going to work. This is going to make the fluid always adhere to the edge of what will eventually be a beaker. That's how we're going to do it. So that's going to help us enormously. Let's just switch back to our 3D view, so F1, and let's continue working on the expression. What we need next are two absolute nodes. So we'll come down to calculate, absolute, first one here, command drag to copy. The absolute node takes away the sign, so we don't want to work with minus values because, of course, when this is swinging around, it can be plus or minus Z, plus or minus X. And we, in terms of its rotational, plus or minus rotation P, plus or minus rotation B, to be more precise. So we want to get rid of that sign and make sure that all of our numbers are positive numbers, and the absolute nodes are going to allow us to do that. The next thing we need are two math nodes, so we'll bring those in. And the function needs to be divide, and we can command drag to copy. Now, we said that we knew the radius of our cylinder was 20, and that was a constant value. So in our divides, if we say we want to divide 20 for our input number 1, we can divide that by, we said we wanted to divide by the cosine of theta. So that's what we'll divide by, and we'll plumb this in here. That completes our calculations and will give us the length of the hypotenuse of our invisible right angle triangle. And that can then be applied to the radii of our circle here and also our first circle within our loft. And that will get our fluid behaving the way we want it to in terms of adjusting its shape. So that's the next thing to do, is to actually bring in our circle here. What I'm going to do, I'm just going to rename these circles. I'll call this one circle 1. In fact, what I'll do, I'll call that circle 3 actually. This one I'll call circle 1 and this one circle 2, because after all these are two working together. So let's bring in circle 1, and we'll also bring in circle 3. Drop these here. For a start, we can come down to our object properties, radius, and also radius Y. They're the two that we're interested in, these two here. So we've got those in, and we can then do the same here. Radius, radius Y. And those are set up, and we can think in terms of where we're going to plumb these things in. Well, it's going to be the output of our top one, which will be plumbed into radius, and the output of our bottom one here that's going to be plumbed into radius Y, and the same thing here. And if you've got this wrong, you just need to swap them over, but it should work. It did in my my practice setup, so it ought to work here, but if it doesn't, that's a simple fix. Okay, the next thing we need to worry about are our rotation B and rotation P, because obviously we don't want the circles to actually stay where they are. We want them to rotate in the same plane and exactly the same way as the pendulum, the actual theta. So that's what we've got to do next. So let's just set this up. So object coordinates, let's have a look. Rotation B and rotation P. And we can do the same here. Let's just bring that in. Rotation B and rotation P. And then we simply need to plumb these in accordingly. Okay, we've got it set up thus far, and we can check to see if anything is actually working. So let's just run the timeline. We'll select the fluid sim null. Let's just run the timeline and see if anything's doing anything. And look at that. It's behaving exactly the way it needs to. Fabulous. Now, the only thing at the moment is that it's perhaps a little bit too dynamic. It's not coming back to its rest state quick enough. If we select our dynamic tag here, our rigid body, we can come into force, and with the angular damping, if we just turn that to say 20. Now let's have another go. If we run the timeline and just move that now, it will gradually start to come to a standstill. It still needs to be quite dynamic, because you've got to remember that this is a fluid. Now, if this was water, it would take quite a while to come back to a rest position, and you can see that it's gradually getting there. Now, this angular damping, the more you turn it up, you can kind of simulate viscosity with that if you wish to. You can make it higher if you wish to, but you can see now it's more or less come back to its rest state. But yeah, that's the angular damping. You can sort of simulate viscosity with that, so bear that in mind. Okay, but that's great. That's all working so far, and it's doing what we want it to. The next step then is to bring in some various other bits and pieces that we can use to control the surface here and make some ripples and things like that on the surface. So we're going to be using a combination of a couple of deformers for that. We're actually going to be using the formula deformer, and also we'll be using the shader effector, and we'll be using that as a deformer. And we'll also use a field in order to control what's happening, because we actually don't want to affect the edge of this, because if we do, it will make things out of sync, and we don't want that. So we're going to use basically a cylindrical field in order to make a fall off to stop the actual edge being touched by either of the deformers. So that's going to be our next step. Let's go into our deformers, and we'll bring in a formula. We'll drop that into our extrude. We can see it's already taking shape, but it's doing something that we don't really want it to. We'll make it 40 by 0 by 40 and fit to parent so that it's in the correct spot. And it's essentially set up pretty much the way we'd like it to be, actually. That's doing what I need it to do, really. Don't really need to do much more. Y radial should be okay. I mean, we can do cylindrical if we wish to, which doesn't really help us. But Y radial should be fine. I mean, if we want to, we can play around with the numbers. We can adjust them accordingly. We can see that they probably will make a difference if we just switch to wireframe, we can see that we're getting some rippling along there. If we make this ×4, again, it changes what's going on. So we can play around with that. We don't want that. That's better. Now we've got a more prominent result now. We can take away that and go back to isoparts. We can see that that's in there. So we're getting a rippling effect. You can keep it really subtle though. I mean, I found that 2 and 2 in there was actually quite adequate. If we run the timeline, we can see that it is making a difference. It's subtle, and subtlety is what we're looking for. But it's up to you. You can art direct this in any way you wish to, but that's pretty much how I'm going to leave it. So we've got our formula effector done. The next thing we need to do is bring in from our, or rather our formula effector, it's our formula deformer. We need to use our effectors next. We just need to bring in the shader effector. We'll drop that under the formula. Once again, what we'll do here is in our coordinates, we just zero everything out so that we get it in the correct place. Just make sure that's there, and then we can work with the shader and see what we want to do with it. Now, with the effector, we don't really need to change anything in there. Parameter, we don't need anything to do with scale. We want position, and we want position Y to be set to 1 centimeter. That's as much as we need to do in there. Now, in our shading, well, for a start with the deformer, we do need to make that polygon. And we can see straight away we are affecting the edge of this, and we don't want to do that. But what we do want to do in our parameters here, we need to, or rather in our shading, I beg your pardon, we need to come into our custom shader here and choose a noise shader. In our noise, we want to change the type to an over shader. I placed my octaves at 20 and my global scale at 120%. And that's as much as I changed in there. Okay, so that's all good. We've got that set up. We've got our effector and our parameters all set up, apart from our transform space, which needs to be object. And we can see that that's made a difference. It started to put a rippling effect on it. But we just need to deal with this edge problem now. And in order to do that, we need to get a hold of a cylindrical field. So we'll grab one of those, drop this under our shader effector. Our field we can clip to shape, but we can adjust its sizes as well. So its height needs to be 3 and its radius 19. And we just need to zero this out. So let's do that. Get it in the right place. And that's looking good. And now we can think about working with our shader. For a start, we need to work with, well, in fact, both of these need to be given in their fields. They need to be given the cylindrical field. So we'll drag that into there. And we can see already that that's starting to work. It's calmed things down. If we just switch to our right-hand view, so F3, we can see that we're getting quite a nice result here. We've got that fall off and we're not touching the edge. So most of what we're actually doing here is happening towards the center. I mean, again, art direction, you can easily change this. If we go into the remapping, the inner offset we can make 75 so that we get a slight difference there. We get a little bit more of it now, and that's probably about right. I don't think you want to go too much further with that, but again, entirely up to you. You're the art director. So that is looking nice. We've got what we want. But we're not finished quite yet, because we still need to go back into our expression, and we need to bring these 3 new objects into here, and we need to give them the rotation P and the rotation B of theta. So let's just set these up. Just get these out of the way. So we want transform rotation, rotation B, and rotation P. So that's our formula. We can just plumb these in accordingly, and it's just a rinse and repeat with the other 2. I'll get them done, and by the power of editing, I'll come back to you. And rotation P, That one's ready, and we can just plumb this in. And that completes the Expresso. That's as much as we need to do. We'll close this down, and then we can see if everything is working as it should be. So let's give this a go. If we run the timeline, we can see that we're getting the rippling effect on there. If we run this, let's just go back to the beginning. Sometimes you need to do that. And now, there we go. It's behaving quite nicely. Okay. Yeah, all looking really quite nice. And as I say, if you don't want the effects, or you just want one of them, you can just switch one of them off, and we've got the rippling is still in there from the formula effector. Or we can just switch off completely. And we can perhaps just use the shader effector if we wish to. You know, so you've got options. And it's working quite nicely. That's the main thing. Let's just zero this out. And then we can think about the final step, which is to build the beaker that the whole thing sits in, because at the moment we just simply got fluid. So we'll do that next, just to finish off. Actually, before we do that, I've realised I've missed a step. I'll select my shader effector, and in the shading, if we come into the noise, we just need to add the animation speed. We just need to make that 1, and in the movement, 0.1, and finally in the speed down here, we'll make that 1. And then if we run the sequence, let's just take the formula off, run the sequence, we can see that we've got quite a nice little effect going there. And that's working quite well. And we'll just bring the formula back in. And that's working exactly as I want it to. So just make sure you do that step. And of course, if you don't agree with any of these settings, please update them and change them to whatever you like. You're the art director. But anyway, that's got that step done. Let's have a go at that beaker. We'll switch to our right-hand view, so F3. And we need to work with snapping, so we'll enable that. Just double check to see what we've got in here. Grid work plane is checked, and we need grid points. So if they're not checked, make sure you set those up. And then we can think about working with our spline. I'm going to zoom a little bit closer, actually, so that we see a little bit more of the grid. Okay. I'll grab a hold of my spline pen tool, and we'll start in the middle of here. Move over to here, and then we can zoom out a little bit, because we need to place a point here, another over here, and then we can get close again. Just see where we are. And we want to come to somewhere around here. We don't want the glass to be too thick. Something like this should be okay, I would think. And then we can come down to the bottom again, drop this down, say somewhere here, and then once again we've got to head towards the middle of the beaker, which is just here where the line is there, and then that should be it. We should be okay. If I just hit escape, I should have a full profile of that spline. Let's just see if we have. I hope we have. What we can do to test that, if we just drop it into, holding the option key, a lathe, let's see what we get. And we do get a beaker. So we've got it. We've actually set the beaker up, and that's looking quite nice. Now, some of the points we can soft interpolate if we wish. I'm not going to bother here. I'll leave it to you. You can do the soft interpolation. But that's the beaker actually created. What I'll also do here is give that a render tag. I'll give it a display tag, use it, and we'll use isopalms, and we'll use lines. And there we go. We've got our beaker. Looking really nice. Now this cylinder, we can make that invisible, so we don't need to see that anymore. And now when we move our fluid, it will look as if it's reacting to the inside of the beaker and adhering to that. So that's looking really good. And of course, if we wish to, we can simply drop our, or in fact we should drop our lathe object into this here. And we can select all of these and group them and call this fluid. And then this lathe, well, we can group that if we wish. We might as well just group that and we'll call this beaker. So we've got everything set up as it needs to be, and we can select this again, run the timeline, and we'll select our axes there, and we can just move this around and we can see that we're getting the result that we want. Great, all looking really good. Fantastic. And as I said before, if you don't like the effects, you can just switch them off. Just remove them completely and you get a flat fluid. Fabulous. And it's all working exactly as it needs to. And that just about brings us to the end of this one. Now, let's think about it. Let's think about what we did. We'll have a quick look at our expression again, and we can see that it's a pretty simple expression. I mean, the key to it is the trigonometric stuff that we're doing here. You know, that's the all-important thing, that using the trigonometry, the cosine rule, to actually get the fluid to always be touching the sides of the beaker. That's the really essential thing. That's the thing that sells it. But simple to set up, and then just basically using rotation B and rotation P to make sure that the circles behave and the various other things associated with them behave in the correct way. The one thing we can't do is treat the cylindrical field in the same way that we can treat the circles. We can treat the circles as ellipses, but we can't do the same with the cylindrical field. So there is a limit to what we can do with this. But it's not a limitation that causes us any major headaches. And of course, the formula and shader effector, well, they can't be changed. Their shape can't be changed. But it doesn't make any odds to them because they just do their jobs regardless. So we're perfectly fine with those two. It's just a pity that we can't do a little bit more with the shape of the cylindrical field, but it doesn't really matter, as I say, on this occasion. And to be fair, it does a very good job, and I would say that in the vast majority of situations, it will be perfectly adequate. And certainly if you give the beaker a nice glass texture, and you probably do a similar sort of water texture for the fluid, you'll actually get a nice result, because the glass will of course cause distortion and you know, with the refractive index of the glass, and that will give it quite a nice look and help to sell it too. So yeah, all in all, it's not a bad little simulation, and it could serve you well in certain respects. But yep, that just about brings us to the end of this tutorial. So as always, I really hope you've enjoyed doing this one, and that it's given you some ideas for things that you may be able to incorporate in your own projects. And if you have enjoyed the video, please give it a like, and if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all of this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings us to the end of this one. So I'll see you very soon on the next tutorial.